Question 1. What do you mean by software testing? Answer. Software testing is the process of evaluating a system to check if it satisfies its business requirements. It measures the overall quality of the system in terms of attributes like correctness, completeness, usability, performance, etc. Basically, it is used for ensuring the quality of software to the stakeholders of the application. Question 2. Why is testing required? Answer. We need software testing for the following reasons. 1. Testing provides an assurance to the stakeholders that the product works as intended. 2. Avoidable defects leaked to the end-user customer without proper testing adds a bad reputation to the development company. 3. Defects detected earlier phase of SDLC results in lesser cost and resource utilization of correction. 4. Saves development time by detecting issues in an earlier phase of development. 5. The testing team adds another dimension to the software development by providing a different viewpoint to the product development process. Question 3. When should we stop testing? Answer. Testing, both manual and automated, can be stopped when one or more of the following conditions are met. 1. After test case execution. The testing phase can be stopped when one complete cycle of test cases is executed after the last known bug fix with the agreed upon value of pass percentage. 2. Once the testing deadline is met. Testing can be stopped after deadlines get met with no high priority issues left in the system. 3. Based on mean time between failure. MTBF. MTBF is the time interval between two inherent failures. Based on stakeholders' decisions. If the MTBF is quite large, one can stop the testing phase. 4. Based on code coverage value. The testing phase can be stopped when the automated code coverage reaches a specific threshold value with sufficient pass percentage and no critical bug. Question 4. What is quality assurance and what are the different activities involved in quality assurance? Answer. Quality assurance is a process-driven approach that checks if the process of developing the product is correct and conforming to all the standards. It is considered a preventive measure. This is because it identifies the weakness in the process to build software. It involves activities like document review, test case review, walkthroughs, inspection, etc. Question 6. What is the difference between verification and validation? Answer. The following are the major differences between verification and validation. Purpose. Verification ensures that the software is being built according to the specifications and design documents. Validation ensures that the software meets the business needs and requirements of the end users. Process type. Verification. A static process involving the analysis of documents, code, and design without executing the program. Validation. A dynamic process that involves executing the software to test its functionality. Focus. Verification. Process-oriented, focusing on whether the software was built correctly according to design. Validation. Product-oriented, focusing on whether the right product has been built for the end user. Questions addressed. Verification. Are we building the product right? Quote. Validation. Are we building the right product? Quote. Cost of errors. Verification. Errors found are generally less costly to fix because they are detected early in the development cycle through document reviews or code inspections. Validation. Errors found can be more expensive to fix. as they are usually detected during or after testing the running software, potentially late in the development cycle. Question point 7. What is SDLC? Answer. The Software Development Lifecycle, SDLC, is a structured process used for developing software applications. It consists of a series of stages that provide a framework for planning, creating, testing, and deploying software. The main goal of the SDLC is to produce high-quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates, and is maintainable and scalable. Here are the typical stages of the SDLC. Requirement analysis. This phase involves gathering and analyzing the requirements from stakeholders to understand what the software should do. It sets the foundation for the entire project. Planning. In this phase, project managers create a project plan, allocate resources, define the project scope, and establish timelines and budgets. Design. The design phase translates the requirements into a detailed architecture. It involves creating design documents that specify how the software will look and function. Development, or implementation. During this phase, developers write the code for the software based on the design specifications. This is where the actual software is built. Testing. This phase involves verifying that the software works as intended and is free of defects. Various testing methods, e.g., unit testing, integration testing, system testing, are used to ensure quality. Deployment. Once the software has passed testing, it is deployed to a production environment where users can begin using it. Maintenance. After deployment, the software may require updates, bug fixes, and enhancements. The maintenance phase ensures that the software continues to function correctly and efficiently. Different methodologies, such as Agile, Waterfall, and DevOps, can be applied within the SDLC framework to adapt to varying project needs and team structures. Each methodology has its approach to executing these stages, with Agile focusing on iterative development and continuous feedback, while Waterfall follows a more linear and sequential approach. Question 8. Explain the STLC, software testing lifecycle. Answer. The software testing lifecycle refers to all the activities performed during the testing of a software product. The phases include requirement analysis and validation. In this phase, the requirements documents are analyzed and validated and the scope of testing is defined. Test planning. In this phase, the test plan strategy is defined. The estimation of test effort is defined along with the automation strategy, and tool selection is done. Test design and analysis. Here, test cases are designed, test data is prepared and automation scripts are implemented. Test environment setup. A test environment closely simulating the real-world environment is prepared. Test execution. The test cases are prepared. Bugs are reported and retested once resolved. Test closure and reporting. A test closure report is prepared to have the final test results. Summary. Learning and test metrics. Question 9. What are the different types of testing? Answer. Testing can broadly be defined into two types. 1. Functional testing. Functional testing involves validating the functional specifications of the system. 2. Non-functional testing. Non-functional testing is a type of testing that involves testing of non-functional requirements of the system such as performance, scalability, security, endurance, portability, etc. Going by the way the testing is done, It can be categorized as 1. Black box testing. In black box testing, the tester need not have any knowledge of the internal architecture or implementation of the system. The tester interacts with the system through the interface, providing input and validating the received output. 2. White box testing. In white box testing, the tester analyzes the internal architecture of the system as well as the quality of source code on different parameters like code optimization, code coverage, reusability, etc. 3. Gray box testing. In gray box testing, the tester has partial access to the internal architecture of the system, e.g., the tester may have access to the design documents or database structure. This information helps the tester to test the application better. Question 10. What is manual testing? Answer. Manual testing is a type of testing that involves validation of the requirements of the application by executing a predefined set of test cases manually without the use of any automation tool. Question 11. What is automation testing? Answer. Automation testing is a type of software testing that involves automated test case execution using an automation tool. It helps in reducing the test execution time, as the test scripts written once can be run automatically any number of times without any human intervention. Question 12. What are some advantages of automation testing? Answer. Some advantages of automation testing are: 1. Test execution using automation is fast and saves a considerable amount of time. 2. Carefully written test scripts remove the chance of human error during testing. 3. Test execution can be scheduled for a nightly run using C tools like Jenkins, which can also be configured to provide daily test results to relevant stakeholders. 4. Automation testing is much less resource intensive. Once the tests are automated, test execution requires almost no time of QAs, saving QA bandwidth for other exploratory tasks. Question 13. What are some disadvantages of automation testing? Answer. Some disadvantages of automation testing are: 1. It requires skilled automation testing experts to write test scripts. 2. Additional effort to write scripts is required up front. 3. Automation scripts are limited to verification of the tests that are coded. These tests may miss some errors that are very glaring and easily identifiable to humans. Manual QA. 4. Even with some minor changes in the application, script updates and maintenance are required. Question 14. What is performance testing? Answer. Performance testing is a type of non-functional testing in which the performance of the system is evaluated under expected or higher load. The various performance parameters evaluated during performance testing are: response time, reliability, resource usage, scalability, etc. The different types of performance testing are: load, stress, endurance, spike, and volume testing. Question 15. What is a test bed? Answer. A test bed is a test environment used for testing an application. A test bed configuration can consist of the hardware and software requirements of the application under test, including operating system, hardware configurations, software configurations, Tomcat, database, etc. Question 16. What is a test plan? Answer. A test plan is a formal document describing the scope of testing, the approach to be used, the resources required, and the time estimate for carrying out the testing process. It is derived from the requirement documents. Software requirement specifications. Question 17. What is a test scenario? Answer. A test scenario is derived from a use case. It is used for end-to-end testing of a feature of an application. A single test scenario can cater to multiple test cases. Scenario testing is particularly useful when there is a time constraint while testing. Question 18. What is a test case? Answer. A test case is used to test the conformance of an application with its requirement specifications. It is a set of conditions with prerequisites, input values, and expected results in a documented form. Question 19. What are some attributes of a test case? Answer. A test case can have the following attributes. 1. Test case ID, a unique identifier of the test case. 2. Test summary, one-liner summary of the test case. 3. Description, detailed description of the test case. 4. Prerequisite or precondition, a set of prerequisites that must be followed before executing the test steps. 5. Test steps, detailed steps for performing the test case. 6. Expected result, the expected result in order to pass the test. 7. Actual result, the actual result after executing the test steps. 8. Test result, pass, fail status of the test execution. 9. Automation status, identifier of automation, whether the application is automated or not. 10. Date, the test execution date. 11. Executed by, name of the person executing the test case. Question 20. What is test data? Answer. Test data is data that is used to test the software with different inputs and helps to check whether the corresponding output is as per the expected result or not. This data is created based on the business requirements. Question 21. What is a test script? Answer. A test script is an automated test case written in any programming or scripting language. These are basically a set of instructions to evaluate the functioning of an application. Question 22. What is an error in software testing? Answer. Since we all are humans, so it is obvious to make a mistake. Likewise, an error is a similar case that happens in software testing due to some missing scenario in the requirements, some issues in design, or some mistakes in the implementation. Question 23. What is a bug? Answer. A bug is a fault in a software product detected at the time of testing, causing it to function in an unanticipated manner. Question 24. What is a defect? Answer. A defect is non-conformance with the requirement of the product detected in production after the product goes live. Question 25. What are some defect reporting attributes? Answer. Some of the attributes of a defect report are: 1. Defect ID, a unique identifier of the defect. 2. Defect summary, a one-line summary of the defect, more like a defect title. 3. Defect description, a detailed description of the defect. 4. Steps to reproduce, the steps to reproduce the defect. 5. Expected result, the expected behavior from which the application is deviating because of the defect. 6. Actual result, the current erroneous state of the application with respect to the defect. 7. Defect severity, based on the criticality of the defect. This field can be set to minor, medium, major, or showstopper. 8. Priority, based on the urgency of the defect. This field can be set on a scale of P0 to P3. Question 26. What are some of the bug or defect management tools? Answer. Some of the most widely used defect management tools are Jira, Bugzilla, Redmine, Mantis, Quality Center, etc. Question 27. What is defect density? Answer. Defect density is the measure of the density of the defects in the system. It can be calculated by dividing the number of defects identified by the total number of lines of code, or methods or classes, in the application or program. Question 28. What is defect priority? Answer. A defect priority is an urgency of fixing the defect. Normally the defect priority is set on a scale of P0 to P3, with the P0 defect having the most urgency to fix. Question 29. What is defect severity? Answer. Defect severity is the severity of the defect impacting the functionality. Based on the organization, we can have different levels of defect severity ranging from minor to critical or showstopper. Question 30. Give an example of low priority low severity, low priority high severity, high priority low severity, and high priority high severity defects. Answer. Below are examples for different combinations of priority and severity. 1. Low priority low severity example, a spelling mistake in a page not frequently navigated by users. 2. Low priority high severity example, application crashing in some very corner cases. 3. High priority low severity example, slight change in logo color or spelling mistake in the company name. 4. High priority high severity example, issue with login functionality. Question 31. What is a blocker? Answer. A blocker is a bug of high priority and high severity. It prevents or blocks testing of some other major portion of the application as well. Question 32. What is a critical bug? Answer. A critical bug is a bug that impacts a major functionality of the application and the application cannot be delivered without fixing the bug. It is different from the blocker bug as it doesn't affect or block the testing of other parts of the application. Question 33. Explain the bug lifecycle or the different states of a bug. Answer. A bug goes through the following phases in software development. 1. New, a bug or defect when detected is in a new state. 2. Assigned, the newly detected bug when assigned to the corresponding developer is in the assigned state. 3. Open, when the developer works on the bug lies in the open state. 4. Rejected, not a bug lies in rejected state in case the developer feels the bug is not genuine. 5. Deferred, a deferred bug is one whose fix gets deferred for some time for the next releases, based on the urgency and criticality of the bug. 6. Fixed. When a bug is resolved by the developer, it is marked as fixed. 7. Test. When fixed, the bug is assigned to the tester, and during this time the bug is marked as in test. 8. Reopened. If the tester is not satisfied with the issue resolution, the bug is moved to the reopened state. 9. Verified. After the test phase. If the tester feels the bug is resolved, it is marked as verified. 10. Closed. After the bug is verified, it is moved to closed status. Question 34. What are the different test design techniques? Answer. Test design techniques are different standards of test designing that allow systematic and widely accepted test cases. The different test design techniques can be categorized as static test design techniques and dynamic test design technique. Question 1. Static test design techniques. The test design techniques which involve testing without executing the code. The various static test design techniques can be further divided into two parts: manual and using tools. Manual static design techniques. 1.1 Walkthrough. 1.2 Informal reviews. 1.3 Technical reviews. 1.4 Audit. 1.5 Inspection. 1.6 Management review. Static design techniques using tools. 1. Static analysis of code. It includes analysis of the different paths and flows in the application and different states of the test data. 2. Compliance with coding standards. This evaluates the compliance of the code with the different coding standards. 3. Analysis of code metrics. The tool used for static analysis is required to evaluate the different metrics like lines of code, complexity, code coverage, etc. 2. Dynamic test design techniques. Dynamic test design techniques involve testing by running the system under test. 2.1 Specification-based. Specification-based test design techniques are also referred to as black box testing. These involve testing based on the specification of the system under test without knowing its internal architecture. 2.2 Structure-based. Structure-based test design techniques are also referred to as white box testing. In these techniques, the knowledge of the code or internal architecture of the system is required to carry out the testing. 2.3 Experience-based. The experience-based techniques are completely based on the experience or intuition of the tester. The two most common forms of experience-based testing are ad hoc testing and exploratory testing. Question 35. What is static testing? Answer. Static testing is a kind of testing for reviewing the work products or documentation that are being created throughout the entire project. It allows for reviewing the specifications, business requirements, documentation, processes, and functional requirements in the initial phase of testing, so that the testers involved in it can understand the requirements in more detail before starting the testing lifecycle, which intends to help in delivering a quality product. Question 36. What is dynamic testing? Answer. The type of testing performed by executing or running the application under test either manually or using automation is called dynamic testing. Question 37. Explain the different types of specification-based test design technique. Question. Answer. Specification-based test design techniques are also referred to as black box testing. It involves testing based on the specification of the system under test without knowing its internal architecture. The different types of specification-based test design or black box testing techniques are: 1. Equivalence partitioning, grouping test data into logical groups or equivalence classes with the assumption that all the data items lying in the classes will have the same effect on the application. 2. Boundary value analysis, testing using the boundary values of the equivalence classes taken as the test input. 3. Decision tables, testing using decision tables showing the application's behavior based on a different combination of input values. 4. Cause-effect graph, testing using a graphical representation of the result or outcome and all the factors that affect the outcome. 5. State transition testing, testing based on the state machine model. 6. Use case testing, testing carried out using use cases. Question 38. Explain equivalence class partitioning. Answer. Equivalence class partitioning is a specification-based black box testing technique. In equivalence class partitioning, a set of input data that defines different test conditions are partitioned into logically similar groups such that using even a single test data from the group for testing can be considered similar to using all the other data in that group. For example, for testing a square program, a program that prints the square of a number, the equivalence classes can be set of negative numbers, whole numbers, decimal numbers, sets of large numbers, etc. Question 39. What is boundary value analysis? Answer. Boundary value analysis is a software testing technique for designing test cases wherein the boundary values of the classes of the equivalence class partitioning are taken as input to the test cases, e.g. if the test data lies in the range of 0 to 100. The boundary value analysis will include test data 0, 1, 99, 100. Question 40. What is decision table testing? Answer. Decision table testing is a type of specification-based test design technique or black box testing technique in which testing is carried out using decision tables showing the application's behavior based on different combinations of input values. Decision tables are particularly helpful in designing test cases for complex business scenarios involving the verification of applications with multiple combinations of input. Question 41. What is a cause-effect graph? Answer. A cause-effect graph testing is a black box test design technique in which a graphical representation of input, i.e. cause, and output, i.e. effect, is used for test designing. This technique uses different notations representing an or, not, etc. relations between the input conditions leading to output. Question 42. What is state transition testing? Answer. State transition testing is a black box test design technique based on a state machine model. State transition testing is based on the concept that a system can be defined as a collection of multiple states and the transition from one state to another happens because of some event. Question 43. What is use case testing? Answer. Use case testing is a black box testing approach in which testing is carried out using use cases. A use case scenario is seen as an interaction between the application and actors. Users. These use cases are used for depicting requirements and hence can also serve as a basis for acceptance testing. Question 44. What is test coverage? Answer. It is a metric that measures the amount of testing performed on software while executing the test. Cases. Test coverage for any software can be calculated as the percentage of the number of test areas or coverage items covered with respect to the total number of test areas. The higher the test coverage, the more the part of the software gets covered by test cases, and hence, the more effective will be the testing. Question 45. What is structure-based testing? Answer. Structure-based test design techniques are also referred to as white box testing. In these techniques, the knowledge of the code or internal architecture of the system is required to carry out the testing. The various kinds of testing structure-based or white testing techniques are: 1. Statement testing, a white box testing technique in which the test scripts are designed to execute the application's code statements. Its coverage is measured as the line of code or statements executed by test scripts. 2. Decision testing, branch testing, a testing technique in the test scripts is designed to execute the different decision branches, e.g. if-else conditions, in the application. Its coverage is measured as the percentage of decision points out of the total decision points in the application. 3. Condition testing. Condition testing is a testing approach in which we test the application with both true and false outcomes for each condition. Hence, for n conditions, we will have 2 n test scripts. 4. Multiple condition testing. In multiple condition testing, the different combinations of condition outcomes are tested at least once. Hence, for 100% coverage, we will have 2 n test scripts. This is very exhaustive and very difficult to achieve 100% coverage. 5. Condition determination testing. It is an optimized way of multiple condition testing in which the combinations which don't affect the outcomes are discarded. 6. Path testing. Testing the independent paths in the system. Paths are executable statements from entry to exit points.